Okay, so for this problem, it's the same problem that we had with ma'am when she was discussing. So let's read up. Calcium chloride is added to canned vegetables to maintain the vegetable's firmness. When added to water, it dissolves. A calorimeter contains 50 grams of water at 25 degrees Celsius. When 1.0 grams of calcium chloride is added to the calorimeter, the temperature rises to 28.51 degrees Celsius. Assume that all the heat given off by the reaction is transferred to the water. What is the heat for the reaction system? How much calcium chloride must be added to raise the temperature of the solution by 9 degrees Celsius? So let's write down all our given. For calcium chloride, 1.0 grams. Water, 50 grams, the same heat capacity as always, and it started off at 25 degrees Celsius. We also know that the temperature rose to 28.51 degrees Celsius, or the final temperature is 28.51 degrees Celsius. So let's try to answer the first questions up. What is the heat for the reaction system? What does it mean by heat of the reaction system? So that's going to look like Q of reaction. So what does it mean by heat of reaction? Is it the heat of the water or the heat of the calcium chloride? Let's try to understand it first. So what is the reaction here? The reaction here is that calcium chloride is being added by water. And when that happens, it dissolves. So the reaction here is that calcium chloride mixed with water will dissolve siya, and it also gives off heat. So may increase ang temperature. How do we know that? Because the temperature from the water kani, it was originally 25 degrees Celsius, right? But later on, it increased to 28.51 degrees Celsius. So we know that because of calcium chloride, ni-increase tayo ng temperature. So the reaction here is calcium chloride dissolves, it releases heat. So the temperature of the reaction is really just the same thing as the temperature of calcium chloride. Calcium chloride. Now we know what to solve for. The thing is though, we can't immediately solve for the heat of calcium chloride because we don't have enough variables good for solving it. But what we do have is enough variables to solve for the heat of water. Now why is that important? That's because the heat of calcium chloride is just the same thing as negative the heat of water. And again, we can solve for the heat of water because everything is just here. So let's try to put that down. Let's try to write that down. So negative the heat of water, no. So we put negative here, and then we solve now for the heat of water. So we have 50 grams multiplied by 4.184 joules per gram degrees Celsius, multiplied by the final temperature, which is 28.51 degrees Celsius, minus 25 degrees Celsius. Put that down in your calculator, and the number you should get, not temperature, the heat you should get is negative 734.292 joules. But again, significant figures. So we have 2 here, we have 4, 4, 2. The least amount is 2, and therefore our answer should only have 2 significant figures. So start from the left, count to the right. So we have 7 and then 3. Our last digit should be 3. But can we round up 3? Let's look at the number on its right. 4 is not greater than or equal to 5, so we can't round up 3. So our final answer should be equivalent to, or approximately to, negative 73 times 10 to the power of 1 joules. Or you could write it as negative 7.3 times 10 to the power of 2 joules. This is just the same thing, it's just up to your preference. So that's it for the first question. We now know what the heat of the reaction is. This time, we're going to be solving for the second part of the question. How much calcium chloride must be added to raise the temperature of the solution by 9 degrees Celsius? So let's write down our given again. So we have calcium chloride and we have water. So it asks, how much calcium chloride must be added to raise the temperature of the solution by 9 degrees Celsius? What does that mean? To raise the temperature of the solution by 9 degrees Celsius. If the temperature was raised by 9 degrees Celsius, then that means that the change in temperature is equivalent to 9 degrees Celsius. And this value is important because we have an equation for heat, remember, which involves the change in temperature. So the equation for heat is mass multiplied by specific heat capacity multiplied by change in temperature. So let's write down our given again. Mass, specific heat capacity, initial temperature, heat, final temperature. So what's the mass of our calcium chloride in this new scenario? It tells us that it's actually asking how much calcium chloride, meaning that we don't know yet by the eye how much calcium chloride should there be in the new scenario. So we're going to leave this blank. But it didn't say anything about water, so we can assume that it's just meaning the same thing. So we can write the same given for the water. 50 grams of water, and the specific heat capacity is, as always, 4.184 joules per gram degrees Celsius. But what about the rest of these? We have initial temperature, heat, and final temperature. Well, the thing is, we can't just write the same initial temperature. And the reason why is because we're already given a new change in temperature. And remember that change in temperature is just the same thing as the final temperature minus the initial temperature. So because we're already given this whole thing na daan, we can't assume that we know any of these alone. So really, we're kind of blind here. We don't actually know the value of the initial temperature, and we also don't know the value of the final temperature. What's even worse is we also don't know the value for the heat of the system. We also don't have any information at all for calcium chloride. So how do we get anywhere with this? How do we find anything? Well, the trick is the fact that it gives us the change in temperature, which is 9 degrees Celsius, means that we don't have to care about initial temperature and final temperature. So if you look at everything right here, we basically have enough information naman di to solve for the heat, because we already have change in temperature, so we don't care about these guys. And the only thing that we're actually missing is heat. So we can actually solve for this. So let's try solving that. The heat of water is equivalent to the mass of water, which is 50 grams, multiplied by 4.184 joules per gram degrees Celsius. And the last part, we have to put final temperature minus initial temperature, right? Again, we don't have to do that because we're already given what the value is anyway, because this is just equal to the 9 degrees Celsius. So instead of writing final temperature and initial temperature, we're just going to write immediately 9 degrees Celsius. So with that in mind, we can now put that in your calculator, and the number that you should end up with should be 1,882.8 joules. So now we know the heat of water. Now that's pretty cool, but like, how is that going to help us find how much calcium chloride we need? Well, just be patient and see how I solve this. So if we know the heat of water, doesn't that mean we also know the heat of calcium chloride? Because remember, the heat of one thing is just the heat of another, but negative. The heat of calcium chloride is just negative the heat of water. And we have the heat of water here, man. So really, the heat of calcium chloride is just negative 1,882.8 joules. Okay, so we can write that down now in our new given. So we have negative 1,882.8 joules, and for water we have 1,882.8 joules. So that's all pretty cool, that's pretty cool and dandy, but how is that gonna help us find anything about the mass of calcium chloride? I mean, if you think about it, we're still missing so many variables. We don't even have final temperature, we don't have initial temperature, we don't have specific heat capacity, and we don't have the mass. So how do we find anything here? So what we have to do is we have to use law of proportions. Law of proportions. So what that basically means is that if you can form a comparison between two variables, let's say you want to find a comparison of mass and heat, if you can find a comparison between those guys, between heat and mass for one scenario, which is the 9 degrees Celsius, then that comparison should be the exact same thing for the ratio or proportion that we had for the last example. And what was our last example? When we solved for the first question, what is the heat for the reaction system? And we know that the heat of the reaction system on the first scenario was, just try to look back in your memory, it was negative 734.292 joules. All over, what was the mass of calcium chloride during the first scenario? it was 1.0 grams. So we know that if this ratio exists for the first scenario, then it must also be equal to the ratio for the new scenario. And what's the ratio for the new scenario, man? What's the heat for the new scenario for calcium chloride? It's negative 1882.8 joules. And the only thing we're missing na lang here is the mass of calcium chloride. The mass of calcium chloride. Now if you look at this whole thing, you can actually solve man the for the mass of calcium chloride. How do we do that? By doing simple substitution or simple transposition. We have to manipulate both sides of the equation so that we can solve for the mass, or we can isolate mass. So how do we do that? So what you want to do first here is we actually want to rewrite everything. You see, this is pretty hard to isolate because mass is below mongod. So even if you get rid of this, you're going to end up with 1 over mass. And that's not the same thing, man, as just mass. So what we're going to do is we're going to find a better ratio or proportion that we can actually use. So instead of heat divided by mass, we're going to do mass divided by heat. So first scenario also equivalent to second scenario. So let's plug in our variables. In the first scenario, the mass of calcium chloride was 1.0 grams. And the heat of calcium chloride at that time was negative 734.292 joules. Now for the new scenario, we don't know what the mass of calcium chloride is, but we do know the heat because it's over here. Negative 1882.8 joules. So how do we isolate M? How can we make sure that M is alone here and there's nothing here at the bottom? So what you can do is you can multiply both sides by negative 1882.8 joules. So what that does is this is going to cancel with the bottom part, and this is going to be multiplied to the top part here on the left. So it's going to be 1.0 grams multiplied by negative 1882.8 joules all over negative 292 joules. So you put that in your calculator, right? And what should come out is approximately 2.56 grams. When you put it in your calculator, the answer is probably going to be pretty long, but this is just a rounded down version here. So this is how it looks like immediately. 2.56 grams. So how much mass did you need for calcium chloride in order for the change in temperature to be 9 degrees? You needed 2.56 grams of calcium chloride. So hopefully that sort of gives you a better idea of how to solve this problem. What basically happened is, first we had to find information for the first scenario, which is the first question here. What is the heat of the reaction system? And then we had to make a comparison or a proportion from that first scenario. In this case, it could be mass over heat, or it could be heat over mass if you want things to be harder. And then if you have that comparison for the first scenario, you can actually do the same thing for the second scenario when the change in temperature was 9 degrees Celsius. That's why we have this equation here. Because again, these are the values for the first column. These are the values for the first scenario, and this is the ones for the second. So you put that equation down, you isolate it until M is alone, you solve for M, and now you have your answer, which is 2.56 grams of calcium chloride.